Hello, I'm going to do another one of these math in the news videos. This time, we're going to look at an article about a dispute about fuel efficiency regulations for cars that the Trump administration and the governor of California have been having. So here's a handout that we're going to have in class, and we'll talk about this in class, but I want you to think about it now. So here's an article from 2018 where attorneys general from 21 states have demanded the Trump administration withdraw its attempt to weaken clean air standards. So the basic idea is that the current rules in California require that the average fuel efficiency across all cars and light trucks sold by 2025 is at least 50 miles per gallon, the 50 mpg. And that's increased from the average right now. In this article, they also talk about the California rules over electric vehicles, and they're going to require automakers to sell at least 1 million in California by 2025, up from 420,000 today. So there's a mathematical question you could ask, and we'll have this in an assignment. Plot the graph from 420,000 today, which was in 2018 on this article, to 1 million in 2025. Do they increase linearly? If so, what would be the slope of that? What would be an equation for that slope? So you would know, if you were a car manufacturer, you would know how many you had to increase. Or it could be that you increase a percent each year as an exponential function. And in that case, you could have a different graph that would be curving faster and faster, increasing faster and faster. What would be the growth factor each year? You'd have to increase by 5% each year, or you'd have to increase by 20% each year. You could figure out something like that. So we'll talk about the math behind that. But for now, back to normal cars, the Trump administration wants to freeze the average fuel efficiency, which is 37 miles per gallon, for 6 more years. So the question is, what's the difference between 37 miles per gallon as an average fuel efficiency and increasing it to 50 miles per gallon as an average fuel efficiency? And so clearly, if you increase the fuel efficiency for a car, the driver's going to save money on gas. They'll need fewer gallons of gas to buy. And how do you estimate something like that? And it says the different organizations have had different estimates. The EPA said it would be about $18.50 per vehicle. And the California's Attorney General said it would be $16.20 over the vehicle's lifetime. So there's a lot of assumptions you can make in there, but there's a lot of interesting math, changing the units to go find some starting point and figure out. The question is, how much money are we talking about as a country? Can you figure out something like that? How much savings would there be in gas cost if you went from 37 miles per gallon to 50 miles per gallon as a country? So think about what are some of the things you could estimate. What are the things you could probably look up? What would you need to find to answer those questions? And you're not going to get an exact value, that's fine, but can you get a reasonable value? And so here's a couple questions in addition to the things I've talked about before. So how many gallons of gas will be saved each year by going from 50 to 37? Is it $1 million? Is it $1 billion? Is it trillions of dollars? Again, we've talked about this in class. As a country, we don't have a good sense at people. We don't have a good sense of the difference. How big is $1 billion? How big is $1 trillion? So I wanted you to think about that. So we're going to break that into groups, and I want your group to think about what would you need to estimate that? What would you have to come up with? What are some ideas? And then can you do the estimation? And then talk about who would save that money. What are the organizations or people or groups that would save or lose based on these things? And how would that go? A second question that you can think about if you have time, or we'll do it later, is to try and plot a graph of this. We've talked a lot about graphs. What would it look like to plot the relationship between cost savings and the increased fuel efficiency? So for an example, you could have on the horizontal axis, you could have the average miles per gallon. And pick in your group or on your own, pick a reasonable scale for that x-axis that includes the relevant values of 37 and 50. It should probably extend a little bit on either side. Probably shouldn't include negative values because that doesn't make any sense, and it shouldn't go much more than 100 because for now we don't have cars that go have that miles per gallon, but it finds some reasonable range. And the y-axis would be the total cost of gas consumption. Plot the 2 points you've got. And now you've got 2 points, you want to model what happens. Could it be linear? If it's a straight line between those 2 points, what does that look like? What's the slope of that? What are the units of that slope? What does that mean? And sometimes we've talked about kind of trying to write a headline for that. So fuel efficiency standards increasing at something per something. What would that look like? And is it linear? How do you tell? Well, maybe you could plot a few other points, plot a few other costs for different miles per gallon. So as the fuel efficiency is increasing over those 5 or 7 years, at some point it's going to be 43 miles per gallon, and then at some point it's going to be 47, and then at some point it's going to be 50. What's the cost for the country to drive if the average miles per gallon is 47? Can you plot a couple of those? And what do you think that, so now what do you think it looks like? Can you explain without numbers, just why should the graph do what it looks like it does? And finally, can you come up with an equation? What's the cost of gas when the average miles per gallon is X? And think about how you calculate that, and you come up with a little equation. And thinking back to your algebra and maybe a pre-calc class you've had before, what's that graph look like? Plot it, see what it looks like, and see if it looks like what you expect it to be. And then we'll come back and we'll discuss these, and we'll go over these as a lot in class. Good luck with this.